Hello everyone. There is another interesting problem that I wanted to share with you. It explains how to use the vectors of speed to solve these kind of problems. So the problem states that a bus is traveling along a road or highway at a constant speed v. You notice the bus when it was at some point A. From which area near the highway can you catch up with the bus if your running speed is u and it's less than v? Okay, so we have a straight road and there is a bus traveling along it at a speed v, and you are standing somewhere here and you want to catch up with the bus. Okay, obviously there are many different ways you could run. Probably you want to run this way, so when bus arrives to point, so initially bus was at point A, probably you want to catch up with the bus at point B. There is another way, you could probably run this way and then catch the bus at point C. It all depends on where you are standing initially, point O, because further you stay away from the highway, I guess you have to turn towards the direction where the bus is going so you can catch up with it. Initially, this problem might seem a little bit challenging. If you draw a picture, it is not that challenging, especially the vectors. So as a man standing at point O here, you might be wondering in which direction you have to run. And also the question is how far you are allowed to stay away from the highway. If you just go too far away from the highway, you will eventually not be able to catch the bus at all. So the question is, which region allows me to catch the bus? So this problem can be solved easily if we just switch the inertial frame. So according to you standing on the ground, the bus is moving towards along the highway at speed v. But according to the people who are sitting on the bus, you are actually moving to the left with the speed v. And then in this inertial frame, we might just stop the bus as if the bus is not moving, but you are moving, passing by the bus at speed v, and then you want to add another speed, your own speed u, so that you would be running towards the bus and be able to catch it. So the man is running at speed v like this, but he also can add his own speed. So that speed could be either this way, u, it could be this way, u, it could be any of these vectors. So eventually, if we draw all the possible directions, you would end up making this kind of a circle. So this vector u, the speed of the man, can be in any direction within this circle with a radius of a u. Okay, so in this inertial frame, so please don't forget that the bus is still, but the man is running along this straight line, which is parallel to the highway at a speed of a v. So this speed is kind of like imposed on this man, so he doesn't have any choice of reducing, because this speed actually initially comes from the speed of the bus. Now, by choosing a specific direction of the u, so our goal is actually to reach the bus, right? So our goal is actually to reach the bus. So we want our resultant speed, our final speed of v plus u. So your resultant speed r is the speed of the bus plus the speed of the person, right? So if we choose this specific u, so let me erase all other unnecessary speeds and they pick only this specific u. If you run in this direction, you will your resultant speed would be this one. R. So this is a speed v, the speed of the bus. This is speed u, and r is your resultant, your final velocity. So if it happens that r is pointing in the direction of the bus, then eventually you will catch the bus. Okay, but it's possible that your initial position, so in this case we can definitely choose a specific direction such that r is pointing towards the bus, right? But what are the allowed region of this r? Can r take any value it wants? It turns out no, it's not. So let me draw another picture. So sorry for making a lot of pictures, but just by drawing a very nice picture, I believe you can just write a very simple equation. So if it happens that our position is slightly away from the highway, let's say this way. So now I'm further away from highway, and then now I don't want the R to be like this. I want it to be pointing towards my bus, right? So we see that by turning the U, by changing the direction of the U, our R vector may take different values. So it might take this value, it might take this value, it might take this value. So we see that the end point of the vector r is always landing on the surface of the circle. So the point at which the r has a maximum angle is the point where it makes a 90 degree with this circle, right? So if it happens that our position is somewhere like this, there is no way you can make your R pointing towards the bus. So in this case, you will not be able to catch the bus, right? So what we can do is we can slowly shift our position like this, such that the R, which is barely touching this circle, is pointing towards our bus. So in this case, obviously, we have to choose a very specific U, which is actually pointing from the center like this, and then it's making a 90 degree with this vector R. So in this case, this is the kind of edge case. So in this case, you would be able to catch the bus, but you would barely be able to catch the bus. So if we make this angle as an alpha, which is same as this alpha, so we know that now there comes the equation part of it. So we know that the sine alpha, just from this triangle, the sine alpha is actually a u over v. Okay, so our alpha becomes arc sine u over v, or you might say the inverse of sine u over v. And overall, the picture looks like this. So eventually there is this highway, there is a bus going at a speed of v, and then you have to draw this kind of line with an alpha of alpha here. If you are anywhere in this region, then you will be able to catch the bus. Okay? If you are outside of this region, so any other region outside of it, you will not be able to catch the bus. This is actually the solution. It's surprisingly short. I barely wrote any equation, but the most important thing is to understand how to manipulate vectors. So if you are happening to be anywhere in this region, here, here, or here, or here, even here, as long as it is within this blue region, you should be able to catch the bus. But if you are outside of that region, anywhere here, here, or here, then there is no way you can catch the bus no matter what. And then the angle at which this region is covered, the blue region, can be calculated by using this equation that alpha equals to the inverse of sine u over v. So your speed u and the speed of the bus v determines the angle alpha. Okay, so larger v means smaller alpha. So if the bus is having larger speed v, then the region covers will be smaller, which means that you have to stay closer to the highway in order to be able to catch it. If v is small, then the angle alpha becomes larger, which means that the region where you can stay in order to catch the bus also becomes bigger. Okay, so that's it. If you liked this problem, please subscribe, like, and leave your comment. Thank you very much.